Oberleutnant Friedrich Weber stood in the captured motor pool, his breath forming clouds in the cold morning air. Around him lay the wreckage of war, burned-out trucks, shattered half-tracks, and twisted metal that had once been vital military equipment. But his attention was fixed on something else entirely. A small, boxy American vehicle sat in the corner, looking almost pristine, despite obvious signs of hard use. The canvas top was riddled with bullet holes. The left front fender bore a crater from a near-miss artillery shell. Half the windshield was gone, yet the engine ticked as it cooled from recent operation, and the tires, though worn nearly smooth, still held air. What caught Weber's trained eye wasn't the vehicle's condition. It was what shouldn't be possible. According to captured maintenance logs from an overrun American supply depot, this particular Jeep had been in continuous frontline operation for 18 months. It had crossed North Africa during Operation Torch, fought through Tunisia and Sicily, participated in the Italian campaign, and now operated in France. The odometer showed 47,238 kilometers, and in all that time, through desert heat and winter cold, through combat and chaos, it had never once been listed as mechanically unserviceable due to breakdown. Weber was 34 years old, a mechanical engineer from Stuttgart who had spent 6 years designing engines for Daimler-Benz before the war. When Germany invaded Poland, his expertise made him too valuable to waste in a rifle company. The Wehrmacht assigned him to technical intelligence, examining captured enemy equipment. His job was to understand how it worked, identify weaknesses, and occasionally discover something the Reich could copy or adapt. Over 3 years, he'd examined dozens of vehicles: British Bedfords, American GMC trucks, captured Russian equipment. Some impressed him, others puzzled him with their apparent crudeness. But this Jeep represented something different, something that challenged everything Weber understood about engineering principles. German vehicles were sophisticated machines, precision-engineered to maximize performance and efficiency. They required skilled operators and regular maintenance, but they represented the pinnacle of automotive technology. This American vehicle looked primitive by comparison. Yet according to every document Weber had reviewed, it simply refused to break down. Weber signaled to Feldwebel Klaus Richter, his senior mechanic, to begin preparations for a complete disassembly. Richter was a veteran mechanic from Munich, 42 years old, with grease permanently embedded under his fingernails. He'd kept German vehicles running through 3 years of war, fighting constant battles against breakdowns, part shortages, and increasingly poor quality replacement components. His initial assessment was dismissive. American mass production, quantity over quality, nothing special. But Weber wasn't convinced. The maintenance log told a story that contradicted everything standard automotive wisdom suggested should happen. This specific vehicle, serial number 2044839, had been in continuous frontline service since November 1942. 29 major engagements documented. It had survived the Kasserine Pass, the fall of Tunis, the Sicily landings, Salerno, Anzio, and now Normandy. By all reasonable expectations, it should have been reduced to scrap metal months ago. Yet according to every entry in that log, the only maintenance performed was routine: oil changes, filter replacements, tire rotations. Nothing structural, nothing catastrophic. The disassembly began at dawn the next morning. Weber assembled his team of 6 mechanics who'd worked with him analyzing captured equipment for over a year. They set up their workspace in a barn the Germans had converted into a temporary workshop, laying out canvas tarps to organize components systematically. The process would take 3 days of methodical work, documenting every measurement, every design choice, every material specification. What they discovered would fundamentally challenge everything Weber thought he understood about automotive design. The first revelation came within hours. Richter removed the Jeep's engine, a small 4-cylinder unit that looked almost comically simple compared to the sophisticated motors Weber was accustomed to analyzing. The engine sat on the workshop floor, still covered in oil and road grime, a compact block of cast iron that seemed unremarkable in every way. The specifications were basic. A simple L-head design with 4 cylinders and side valves, nothing sophisticated. The entire engine produced only 60 horsepower from 134 cubic inches of displacement. For comparison, the German Kübelwagen produced more power from a smaller engine. By every measure of efficiency and specific output, this American engine was inferior. Yet this particular engine had run for 47,238 kilometers through desert heat exceeding 120 degrees Fahrenheit and winter cold dropping below 0. It had been driven at full throttle across rough terrain, through rivers, across mountains, and over roads that barely deserved the name. It had operated on fuel of varying quality, sometimes mixed with sand and contaminants. It had been maintained irregularly, often by soldiers with minimal mechanical training, using whatever oil happened to be available. And despite all of this abuse and neglect, when Richter turned the key, the engine caught immediately and settled into a rough but steady idle. Weber crouched beside the engine block, examining it with the critical eye of an engineer who'd spent years designing high-performance motors. The block was cast iron, heavy and crude by German standards. The head was simple. The valve train was straightforward to the point of being primitive. No overhead camshaft, no advanced metallurgy, no sophisticated fuel delivery. Just a basic carburetor feeding fuel to 4 simple cylinders. The sophistication, Weber realized, was in the simplicity itself. Every component was designed to be robust rather than efficient. The L-head configuration was decades old, yes, but it was also nearly indestructible. Side valves were less efficient than overhead valves, producing less power per unit of displacement, but they were far less likely to fail under stress. The heavy cast iron block absorbed heat and vibration that would crack lighter alloy designs. The simple carburetor could be cleaned and adjusted with basic tools in field conditions, unlike the more complex fuel injection systems German engineers favored. The team continued their systematic disassembly over the following days. Each component told the same story: deliberate over-engineering for reliability at the expense of efficiency and performance. The transmission was a revelation in its own right. 3 forward gears plus reverse, with a 2-speed transfer case providing low-range gearing for difficult terrain. The entire unit was housed in a heavy cast iron case, sealed against dust and water intrusion. When Richter drained the transmission fluid, he found it still adequate, despite obviously never having been changed in 47,000 kilometers of operation. The gears themselves showed wear patterns consistent with hard use, but no actual damage, no broken teeth, no stripped synchronizers, no failed bearings. The entire transmission had been designed with gear spacing so wide that even incompetent drivers grinding gears constantly couldn't easily damage the mechanism. The synchronizers were over-engineered for the power levels involved. Every bearing was oversized. Every component had massive safety margins built in, far beyond what German engineering practice would consider necessary or efficient. The suspension revealed the same philosophy. Simple leaf springs front and rear with basic hydraulic shock absorbers. Nothing sophisticated, nothing requiring special tools or advanced knowledge to service or repair. But the springs themselves were manufactured from high-quality steel with generous thickness and careful heat treatment. The shock absorbers were rebuildable units using standard parts. The entire suspension system could be repaired in field conditions with minimal equipment by a mechanic with basic training. The axles were solid units front and rear, housed in thick cast-iron differential cases. They were heavy, inefficient from a power transmission standpoint, and absolutely bulletproof in terms of durability. Weber's team measured the differential gears and found wear patterns from 47,000 kilometers of operation, but no damage whatsoever. The bearings showed use but remained perfectly functional. Most remarkably, the seal quality throughout the axle assemblies was extraordinary. Despite multiple documented water crossings where the vehicle had forded rivers and streams, no water had penetrated the axle housings to contaminate the lubricant. But it was the electrical system that truly amazed Weber and forced him to reconsider fundamental assumptions about automotive design philosophy. German military vehicles of the era utilized sophisticated 12-volt electrical systems with complex wiring harnesses. The systems were efficient and capable, providing excellent performance when properly maintained, but they were also delicate. Combat damage to wiring often meant hours of troubleshooting to locate failures in the complex harnesses. Moisture caused chronic problems, particularly in the damp European climate. The systems required skilled electricians to diagnose and maintain, specialists who were increasingly difficult to find as the war ground on. The Jeep's electrical system was brutal in its simplicity, a 6-volt system with heavy-gauge wiring throughout every circuit, minimal complexity anywhere. The entire wiring harness could be traced by eye, with each circuit clearly routed and protected. Every connection was oversized for its current load and weather-sealed against moisture intrusion. The battery was a simple lead-acid unit positioned high in the engine bay, where it stayed relatively dry even during water crossings. The generator was a simple brush-type unit that produced adequate charging current even at low engine RPM, meaning the battery stayed charged during extended low-speed operation. One of Weber's younger mechanics discovered that the distributor cap showed clear evidence of water immersion, a visible waterline across the bakelite housing. Yet the ignition system had continued functioning even after submersion. The cap was molded with deep grooves specifically designed to prevent electrical tracking when wet. The rotor was simple but effective. The points were accessible without tools. The entire ignition system could be serviced in minutes with minimal equipment by someone with rudimentary electrical knowledge. By the evening of the third day, Weber had compiled enough data to understand the complete picture. The Jeep represented a fundamentally different design philosophy than anything in German military inventory. where German engineers optimized for performance and efficiency, pushing components to operate near their stress limits to maximize output. American engineers had optimized for reliability and maintainability under the worst possible conditions, accepting significant penalties in weight and efficiency to achieve near absolute mechanical reliability. Every single component of the Jeep embodied this philosophy without exception. The fuel system used a simple mechanical pump and basic filtration that could be serviced with common tools. The cooling system was deliberately oversized for the engine's power output, meaning it would never overheat even under sustained hard use in extreme temperatures. The frame was constructed from heavy channel steel with massive cross members providing structural strength far exceeding what calculations suggested was necessary. The body panels were stamped from thick steel that could absorb significant combat damage and still function. Even the seats were designed for durability over comfort, simple metal frames with canvas covers that could be replaced in minutes. Weber assembled his findings into a comprehensive technical report. The specifications were straightforward, but the implications were profound. The Americans had created a vehicle that sacrificed everything German engineering culture valued: efficiency, performance, sophistication, in favor of a single attribute: absolute reliability under any conditions. The strategic mathematics were simple but devastating. The Jeep weighed 2,315 pounds empty, heavier than necessary for its size and capability. It consumed fuel at a rate of approximately 16 miles per gallon, poor by efficiency standards. The power-to-weight ratio was mediocre. By every traditional measure of automotive excellence, the Jeep was inferior to its German equivalent, the Kübelwagen. But the Jeep possessed one characteristic that trumped every performance metric. It didn't break down. It operated in temperatures ranging from 130 degrees Fahrenheit in North African deserts to 30 below zero in European winters. It could be driven through rivers, across mountains, through mud that would stop more sophisticated vehicles. It could be maintained by teenage farm boys with minimal mechanical training, using whatever tools happened to be available. It could be repaired in the field by soldiers working in foxholes during combat operations. And most critically, it kept running. Day after day, month after month, through conditions that would destroy more sophisticated equipment, the Jeep simply functioned. The maintenance logs Weber had captured documented this reality across thousands of vehicles. Operational readiness rates for American Jeep-equipped units consistently exceeded 90%, a figure German mechanized units couldn't approach even with extensive maintenance infrastructure. The strategic implications were staggering. American forces could maintain mechanized mobility with minimal logistics support. Complex maintenance facilities weren't required. Specialized repair equipment wasn't necessary. Highly trained mechanics weren't essential. The vehicle could be operated by personnel with minimal training and maintained by soldiers with basic mechanical aptitude. This represented a force multiplier of immense magnitude. Weber's report included detailed technical drawings, material specifications, and comparative analysis with German equivalent vehicles. He documented the oversized design margins built into every component. He calculated the massive safety factors the Americans had engineered into structural elements. He analyzed the material quality and manufacturing precision that allowed such robust construction. His conclusion was stark. The Americans weren't trying to build the best vehicle. They were trying to build the most reliable vehicle. And in the context of global industrial warfare, reliability represented a more valuable characteristic than any measure of performance. A vehicle that always worked was worth more than a vehicle that worked brilliantly when it worked but failed regularly. The tragedy, Weber noted in his final assessment, was that Germany could no longer replicate this approach even if they wanted to. The Jeep's design philosophy required unlimited access to high-quality steel, rubber, copper for electrical components and manufacturing capacity. It required the ability to deliberately over-design every component, accepting weight and efficiency penalties to achieve reliability margins. Germany in 1944 lacked these resources. The Reich was fighting with increasingly limited materials, using substitute components and stretched manufacturing capacity. They couldn't afford the massive safety margins the Americans built into everything. Weber's report was filed, distributed up the intelligence chain, and largely ignored. By mid-1944, Germany's strategic situation made fundamental changes to design philosophy impossible. The war machine was committed to existing production schedules and existing designs. Resources were too limited to consider major redesigns even if the engineering principles made sense. But Weber's analysis was prophetic. The Jeep's influence on post-war vehicle design would prove enormous. Every nation that captured or received Jeeps during the war studied them intensely. The Soviet Gaz-69, the British Land Rover, the French designs, the Japanese Toyota Land Cruiser all showed clear influence from Willys MB design principles. Simplicity, reliability, and maintainability became standard requirements for military vehicles worldwide. The final irony came as Weber's team reassembled the Jeep after 3 days of complete disassembly. After being taken apart by enemy mechanics in a cold French barn, with every component examined and measured, then reassembled with minimal care for proper procedure, the vehicle was reconnected and fueled. When the ignition key was turned, the engine caught on the first revolution, settled into its characteristic rough idle, and ran perfectly. No adjustment needed, no troubleshooting required, just simple, reliable mechanical function. The Jeep they examined that week survived the war. It was recovered by American forces during the final push into Germany, returned to service, and eventually shipped back to the United States in 1946. It passed through military surplus sales and several civilian owners before being donated to a military vehicle museum in Pennsylvania in 1978, where it remains today, fully operational and occasionally driven in parades 76 years after its manufacture. The production numbers tell the story more powerfully than any analysis. From 1941 to 1945, American manufacturers produced 647,925 Jeeps. Willys Overland built 361,339 units. Ford, manufacturing to Willys specifications, built 277,896 units. They were shipped to every theater of war: Europe, North Africa, the Pacific, China, India. They served with American forces, British Commonwealth armies, Free French units, Soviet forces provided through Lend-Lease, and Chinese forces. They hauled supplies towed artillery, carried wounded soldiers, mounted weapons, performed reconnaissance, and became the universal symbol of Allied mechanized mobility. The casualty rate among Jeeps was extraordinarily low considering their frontline service. Most losses came from direct combat damage, artillery hits, mine strikes, or intentional destruction during retreats to prevent capture. Mechanical failures in field conditions were rare enough to be noteworthy when they occurred. Post-war surveys found that Jeeps maintained operational readiness rates exceeding 90% even under sustained combat operations, a figure unmatched by any other military vehicle of the era. Weber's insight, documented in that barn in Normandy in 1944, identified the fundamental principle that made this possible. The Americans had deliberately eliminated sophistication wherever it introduced failure potential. They had built massive redundancy into every system. They had used higher quality materials than strictly necessary. They had engineered safety margins into every component that far exceeded calculated requirements. The result was a vehicle that could absorb incredible punishment, operate in any environment on Earth, be maintained by untrained personnel with improvised tools, and still function perfectly after years of continuous frontline service. This wasn't accidental. It was the result of a deliberate design philosophy that prioritized one characteristic, reliability, above every other consideration. The secret that German mechanics discovered when they opened that captured Jeep wasn't a revolutionary technology or hidden innovation. It was something far more profound and far more devastating to German strategic prospects. The Americans had won the engineering war not by building superior technology, but by building technology so reliable it never failed when lives depended on it. They had created a machine that simply could not be broken by normal use, no matter how hard that use might be. In doing so, they had created the most influential military vehicle in history, a design so fundamentally sound that its basic principles continue shaping military vehicle development 80 years later. The Jeep proved that in warfare, the simple ability to keep running day after day, mission after mission, without failure, represented a strategic advantage that no amount of sophisticated engineering could overcome. Weber's analysis had identified this truth, but by the time he wrote his report, it was already too late for Germany to do anything about it.